Let's look at problem 2294. First, I will analyze the problem, then I will give an example, and finally we'll give the code and also explain some of the subtle details. So first, let's look at the problem. So we are given an integer array called numbers and an integer k. So we may partition numbers into one or more subsequences such that each element in numbers appears in exactly one of the subsequences. So we are required to return the minimal number of subsequences needed such that the difference between the maximum and minimum values in each subsequence is at most k. So here, one thing we want to emphasize is that we are considering subsequences, so not subarray. So a subsequence is a sequence that can be derived from another sequence by deleting some or no element without changing the order of the remaining elements. So here, one point to notice is that so within each of the subsequences, we are going to obtain so the maximum value and minimal value, the difference should be bounded by k. So notice that so the minimum or maximum of a sequence does not depend on the order of the element. So that's one of the points. So here the problem gives several examples. And let's look at the constraint first. So here the length of the numbers can be up to 10 to the power 5th, and the second constraint is about each of the elements, which is non-negative and bounded above by 10 to the power 5th, and also the k as a difference target k is greater or equal than 0 and less or equal than 10 to the power 5th. So let's look at one example. So actually, the first example is sort of typical. Let's look at the case. So here we have numbers, which is 3, 6, 1, 1, 2, 5. Here k is 2. So in order to do this, let's first make the main idea. So main idea is this. So we want the absolute value of minimum or maximum is bounded by k, right? So the problem itself is required is at most k. In other words, it's less or equal than k. So here is the thing. So in order to make the partition, we can first sort numbers. So for example, after sorting, the numbers change to something like this. So let's sort from small to large, and 3, and 5, and 6. Then we can go over the step like this. So we can pop the last element, 6, and then we can pop again, and so 5. So we check whether the distance of the current element and the 6 is within a k. So 5 minus 6 in absolute value is 1, which is less or equal than k, because we have actually sorted the numbers array. So each time when we do a check, the first element, we can regard it as a representation of the subsequence starting from that one. So then the element we are going to add into this specific subsequence is going to be smaller or equal to this number. So we just need to check the number we are going to pop plus k less or equal than the first element. So now let's check pop 3. Then 3 plus 2 is less than 5, right? So in other than 6, it means the distance between 3 and 6 actually is greater than 2. So 3 cannot put into the subsequence starting from 6. So we restart. So now we have 3. Then we pop again. So we get 2. 2 plus 2 actually is greater than 3. So it means the distance between 2 and 3 is less than 2. Then we pop again 1. So 1 plus 2 is greater or equal than 3. It means the distance between 1 and 3 is again less or equal than 2. Here actually it's equal. So now imagine if we have another number. So for example, let's see, 0. Then we cannot add 0 to this one, because 0 plus 2 is less than 3. It means that the distance from 0 to 3 actually is greater than k, that is greater than 2. Right? So in this case, we are going to make 0 a subsequence itself. So in other words, the essence of the problem actually is a sort of partition of a set. But we allow repeating elements. So we talk about partitioning a subarray. So with that said, actually, it's very easy to write a solution. So we can first sort the numbers. Then we began to do a greedy pop, and in the process, in each of the subsequence, the first element is going to be the representation of the subsequence. So then we continue popping and check if that number popped has a distance less or equal than k from the first element, the representation, because here actually we are using something like if the absolute value of the min and max is less or equal than k, then adding two elements within the subsequence is bounded by k in absolute value or in distance, so to speak. So here the main idea is like this, and the key point is that how do we check the distance is at most k. So if we are using the largest element to represent a subsequence, then we're going to, when we pop a new element, we just need to check if the new element plus k is greater or equal than the largest element. Right. So if we are using the smallest one, we are going to check if the current element minus k is greater or equal than the smallest element. So with that said, let's comment this out and write a solution. So here for this problem, I'm going to write two form of solutions. The first one is two while loops, which mimics the process we demonstrated above. And also we are going to write a single for loop solution, which actually abstract a little bit about the solution. Let's first look at the two while loop solution. As we mentioned, first let's sort the numbers. So here I'm sorting in a natural order, in other words, from smaller one to larger one. The reason is that I'm going to use maximal element to represent a subsequence, because we are using pop. This is a little bit faster. So then we can initialize a result variable, which at the very beginning it's set to be 0. Then we can see, as long as the numbers array is not empty, then we are going to pop one element. So this is the current max, so which is nums pop, right? Pop from the tail of the numbers. Then what we do, we can see how many elements we can add to the current to the subsequence starting from with the maximum value equals to current max, right? So here we check if nums is still not empty and nums, the last element, so the current largest actually, then plus k is greater or equal than current max. Right? So this condition actually means the current number nums -1 can be added to a subsequence containing current max. If this was the case, we are going to continue pop. Then actually after we get out of the while loop, so either nums is empty, or the last element in nums has distance further than k from the current max, which as we can see, we cannot add the last element in numbers to the subsequence containing current max. So after this while loop, we increment the result by 1. Right? So then, once we done this for loop, so we'll just return the result. That's it. So let's see. In this process, actually we use a sort. Sort is an n log n algorithm, where n is the length of numbers. So here also we have a while loop. So essentially this while loop is linear because we just scan the whole nums once. So let's check if it works. So this is for a generic case. For a special case, then we can submit for a general case. So with this, actually, let's look at another solution. Because once we notice the essence of the problem, the solution, we can just simplify a little bit. So we do not need to just mimic. We just need to sort, then just check the element just using one for loop. So here, let me do things like this. Num sort. So here we are sorting using natural order, right? So next we are going to initialize and things to return the variable we call it answer to distinguish from the result in the above solution. So and we are using current max or current. Let's using current. This is the first element. So this is the smallest one. So then we just scan for y in nums. What we want to check? We want to check if y and current has a distance is within k, right? Because current is the smallest, so we just need to see if y minus current is greater than k. So if this is greater than k, it means the current number y has a large distance. We cannot put into same subsequence with the current. So in this case, we reset the current by y, and then we increment answer by 1. So this is natural, right? Then we just return the answers. So this the second method is not identical rewrite of the first method, because the first one is going to using pop, and we are starting from the largest one in each of the subsequence. And in the second solution, we are traversing from the beginning to the end. We are representing each of the subsequence using the smallest number. So let's check this for a special case, and then check for a general case. Yeah, so it passes the test. Yeah, that's about it. Thank you.